All right, so we're getting familiar with our radical expressions. Now we're going to look at multiplying radical expressions together. So how can you write an expression for the product of 3 times the square root of 5x multiplied by 2 times the square root of 15x to the third? All right, so one thing we need to know about multiplying radicals is you can multiply radicals together and you can multiply non-radicals together, if that makes sense. So what I mean by non-radical, basically these numbers in front of the square root, this 3 and this 2, are going to stay in front of the square root. So we're going to have a 3 times 2, and then multiplying square roots is just using that product of square root property backwards. We can put those back together underneath the same radical. 5x times 15x to the third. So you can multiply square roots together as long as you're taking the square root of both values, or whatever we're calling those. You put them under the square root together. So 3 times 2 is 6. Square root of, now we're going to multiply these together. The 5 and the 15 will multiply together to give us 75. And then we'll multiply the x's, x times x to the third. When you multiply variables, you add your exponents, and we get x to the fourth power. Now the problem is just like what we did in our last video, where we're going to try to reduce this radical. So we have a 6. Let's do something to catch our eye at the end of the problem. We don't want to forget that 6 is there. Square root of 75 times x to the fourth. All right, can we rewrite 75 with a perfect square factor? So think through. You've got 4, 9, 16, 25. All right, 25 is the one. 25 times 3 gets us 75. And then x to the fourth power. All right, so the square root of 25 is 5. The 3 stays. Square root of x to the fourth. So that's an even exponent. We're going to be able to square root this perfectly without any leftover x's. How many x squareds fit into x to the fourth? 2 of them. Here, if we want to see it, remember x squared times x squared. Because there's 2 of them, when you square root those, you will have an x to the second power. The 6 comes down. These 3 get multiplied together. 6 times 5 times x squared is 30. X squared times the square root of whatever was left underneath. We had that 3. And there is our final answer. All right, so we're going to try a couple more examples. When we do our multiplication, anything out in front gets multiplied. 1/2 times 4. And then anything, basically these radicands, remember that word from our vocab? Those go underneath the radical together with multiplication. 21 x to the third times 7x squared. Let's take care of some of this multiplication. 1/2 times 4 is 2. Square root of, we're going to multiply the 21 times the 7. That's going to get us to 147. And then x cubed times x squared. Add your exponents to get x to the fifth power. All right, so let's be aware we have this 2. But now we're going to rewrite this 147. So 147, 4, 9, 16, 25. Honestly, I don't know what goes into 147. I would grab my calculator and start dividing. When you do that, you're going to get to 49. 49 times 3. There's a perfect square factor that fits into 147. And then times our x to the fifth. All right, so we have our 2 that's going to carry down from out front. Square root of 49 is 7. This 3 stays. Square root of x to the fifth. So how many x squareds fit into x to the fifth? 2 of them. so x squared. And then we have a leftover 1, so I'm going to cross that off and put the leftover up top so I know that that stays underneath the square root. All right, everything that we took the square root of or carried down gets multiplied. So we have a 14x squared times the square root of, we have a 3 and an x, so 3x. All right, one more. We have a 2, nothing out in front, so the 2 stays in front, times 12x to the 9th times 18x to the 5th. Let's go ahead and multiply together. 12 times 18 is 216. X to the 9th times x to the 5th is x to the 14th. All right, now let's grab this 2. Let's not forget that's going to come down. This 216. We grab our calculators, we start dividing. 216 divided by 4, 9, 16, 25. You might find that 4 fits in, or 9 fits into 216. You do want to find the biggest perfect square factor. In this case, 36 is the biggest perfect square factor, and it fits in 6 times. How do you know if you have the biggest perfect square factor? So here's what I do. If I'm looking at 216, I divide it by 4. 4 fits in 54 times. I take a look at that other factor. Do any perfect squares fit into 54? I would say, well, yeah, 9 does. So if that answer is yes, that another perfect square fits into this other number, then 4 is not the biggest one. When we keep going, we would get 9 times 24. So we check the other factor. Do any perfect squares fit into 24? Yeah, 4 does. That means there's something bigger than 9. We get to 36. 36 fits in 6 times, so we check the other factor, the non-perfect square factor. Do any perfect squares fit into 6? Nope. That means 36 is the largest perfect square factor. All right, so I'm going to bring down back to our problem. We have 36 times 6 times x to the 14th power. And now let's take our square roots. So the 2 carries down. Square root of 36 is 6. That 6 stays. X to the 14th, that's an even exponent, so this will square root perfectly with no leftover x's. How many x squareds fit into x to the 14th? You can fit 7 of them, so we're going to have x to the 7th power. All right, all of this down here goes out front. 2 times 6 is 12 times x to the 7th, and then anything left underneath the square root stays under the square root.